So today, essentially, we will discuss some more important aspects related to Python programming. So we will start by how to create a module. For example, you want to create a module. So how to do that? So first thing we will do that. So I have again opened, let's say my Jupyter notebook, where what I'll do, I'll call this, let's say Python session 3, and then rename it. Okay, so now what I want to do, I want to create a module for my work. So I open the spider also. Let's say spider I'll open, and then we will work with the spider also. So I want to share this screen also. Please let me know if you can see my spider window. Okay, share. So you can see my spider window, right?
Yes, sir.
Okay, so spider you can see. So what we are going to do, let's say we want to create some function, and that, like, a module is nothing but a collection of functions. You can have different attributes, and then you can have classes or collection of modules. A module could be a collection of modules, and which could be a collection of Python functions and classes. So we want to define some function, let's say. So just for very simple thing that we want to define, since we need it for just working with our module. So let's say I define a very simple function. This is called, let's say, function 1, and then which returns some value. You can have a very complicated function also, but that is not the idea, just how the module works. Since once you have, this, whatever function is there, you can use it. So let's say I have a very simple function, and then I also write the description of it so that we can see. So you can see that how the description look like. So automatically it is taking parameters x, y, and return. So this is the standard practice that you say parameters x and y. I can say these are basically floats, and then similarly. So there is a very nice setup here. So you can say this is also floats or float. And then what it returns, that it's saying is that you can return the sum of squared, which is again a floating point number, and that is the description of this function. So in this way, I can define another function just quickly so that we understand that we can call these functions. And then I can say that you can define, it doesn't matter whether it is the same thing work for the very complicated function. So it is. So again, I say that, okay, I can write this function returns the multiplication of two numbers. So to save the time, you have taken just simple functions. Now what happened? This function just return, since every function has to return something, otherwise generally that is the purpose of the function, so that you generate some value from this. So now we have these two functions, right? These two functions, return x and y. So now what I do, I save this. Let's say I save it, and I want to save it on my desktop. And then I call this my, let's say, or you can say module. This module only has two functions, but this is a module. It can have more functions, 100 functions. That is also a module. So I call this module1.py. That is the way that you have to save it as a Python file, module1.py. And then what I do, generally I go to my desktop, and you cannot see my desktop, but what I'll do it, I'll put this in a folder so that I have a collection, and that is, so I can call this function, this folder also module. So I have a folder module, and I place this whatever we have written in that folder. And now we are ready. So what I have done, I have created a module with two functions only, that is the function 1 and func 2. And then that is I have stored in a folder called module on my desktop. Now suppose I want to import it. Let's say import module. That the name is, just let me check quickly this. The name is module actually there. So let me call that import module. So it is showing an error. It is saying that no module named module exists. So that's why I cannot call it. So the reason is that the my desktop folder, basically that is not in Python memory. So Python doesn't look the file stored on the desktop. So I have to store that file either to where Python look, or I have to add the path of desktop or that module folder to Python memory. So there are two ways. So what I do, I can see that where the Python can look directly. So there is a way import sys. So sys is basically related to system. This is related to system library, you can say, which look for paths and other things, system library, or which deal with the system. So this is a system package that I import. And then what you do by sys, and then you can see that what are the paths it look actually. So you can see that these paths, Python can directly look in these paths if something is stored with the name module, capital MODULE. So, but you see that there is no desktop here. Desktop path is not there. These are just connected to Anaconda libraries, and then this one Arun S library, and then other things. So this path is not available. So one approach is that I can add my path here, system dot let's say my path, and that append. So I want to add the path where I have stored my module, and then I go there, and then I basically, as you go in that folder and you see the properties to copy the path. So that I will do. So to copy that path, I have to bring that part by copying from there, and then we have to add it here. String, and that is this path, module, inside the module. So this is the path where I have on my desktop the module available. So now I add this path, enter. So what it's saying that, okay, this actually I should not give, I think this one. So now this path is added. So this path is added to the, and now you can see that in sys.path, this path is also available now. My desktop where I have. So this path, the last one that I have appended, is my desktop. And then you can say that import, and the name we have given there is module 1. That we have given the name import module 1 actually. So now Python has imported this. That module it has imported. Now it understands the path. Import module 1. And now I can use those functions that we define, module 1 dot func. Function 1, function 2, you can see that these are coming here now. So function 1, which was essentially squaring something. So 2 and comma 3. So it is giving 13. So that is like 2 square plus 3 square. That is 4 plus 9, 13. Similarly, I can call my whatever functions are there. We have only just two functions. So module 1 dot, you can call another function, function 2, which is just multiplying two numbers essentially. Just for simplicity, we have taken very simple function. So this is giving me the 6. So in this way, what we have done is, you have essentially first created a collection of functions, and then you have basically stored those functions in some folder, and you can save that folder in your computer anywhere. But only thing is that Python, where Python actually is executing, or Python only understand, it doesn't have access to your whole computer essentially. So it cannot access your computer without your permission. So it has access to some folders where you have given the permission, and so you have to see where it can see. Either you can put that folder in those paths where it can see, or you have to add the path by using the system as sys thing. So sys.path.append, by that way you have to add that part, and then it comes under the Python memory, and then you can basically work with it, right? So next thing is that, okay, next thing is, you can also see from here, you can also collect the doc string, that module 1 dot, it hope it should be accessible from here, dot. So there is a, these are the Python functions actually. So these functions are Python, when you have double underscore dot double underscore kind of functions. So these are the Python functions automatically defined basically there, like Python special functions. So they are defined by dot underscore. So you can see that you can access that whatever we have written here. So there is a new line, new line, parameters, new line is coming, floats, then, so there is a, like, some new lines are there. So that's why this is not coming correctly. So whenever there is a new line, so it was backslash n for the new line. So maybe we can modify it. So for example, okay, so if you see that this doc string, so we can remove these new lines here. So it should start exactly from here, and then you have floats, and then you can have new lines, and then you can also remove this line if you don't want there's too much new lines there. This one. So this way it will remove some new lines from there. So I just made some changes in that, and then we just see this one again. So import module 1, and then it should actually remove those lines actually from it. It should, I'm not sure why it is not removing, but it should remove those lines. So you have to save it and read it again. So that is the thing. So hope it is saved like this. Save here. So that way you can see that the help, and similarly you can see whatever the function can do just directly here, where that is stored on my computer by doc string function. So sorry, dot underscore doc, and then you can see that this function returns the multiplication of two numbers. That is the doc string for the second function. So in this way, the good part is that you can collect. So generally, you can collect all these things as a basically you can collect all these things, and then you can see basically the, like, what this function is doing. And as we also discussed last time, that you can also see directly by just doing, you have one, and then you can use question mark, and then you put enter, and then you can see nicely. Here it is coming nicely. Then the doc part. So you can see that, okay, this coming X floats, Y floats, return some square, which is again a float. So all this is our module that we have defined. This is not Python module, but what we have done, you have created a function, you have created, let's say, collection of functions. You save it as a .py file. Remember that you have to save it as a .py file. So the steps are, since we are online, so essentially we have to be, I have to write it. So steps to create your module, that is step 1. So you can write here step 1, like create a collection of functions, classes, Step 2, basically you have step 2, save it as a .py file in some folder on your computer. Step 3 is basically add the folder path using sys library from Python. So you have to add the path, and then what you have to do, the step 4 is just to import the module using import command. So then your final module is, you can do like this. So then you have your module available. Okay, so we are done with this. So next thing, that is a very important concept, that is called basically class. So that is called Python classes. Python classes. Okay. So you can create a Python class just by simply writing the class, and then you can give the class name. So we can call this class 1. This is the class name. And then if you don't want to do anything, then you can just say that, okay, pass. So this means this is a class with class 1, but doing nothing. So then you can, so this is a class. So what we can write, this is a Python class with name class 1, but doing nothing. Okay. So this is the class. So you have to, so if you leave it here, you don't do anything, then this is not complete. Okay, it should, this is not complete. So anyway, you have to pass something. So generally we write this pass so that it doesn't create any problem. Okay. Next thing is that we want to do a class which do something at least. So let's say we have another class basically, and that is called, let's say we call this math function some class, and then we can also write this, there is no harm in this, and then it can be just again I'm writing. So this is a class with some math functions. So you can define, let's say, some functions here, and then as we did last time, we can copy these functions from here for your help. Rather than going there, we copy these functions. So it has, let's say, two functions, which basically function 1 and function 2. So this can be a class. Now what happened that this class can be used just by, what is there? Let me see what is the issue. Okay. So we have to basically have the indented block. So this block is not indented. We have to shift it. So essentially we have to shift it. So shift. Okay. Just actually this is, there is an indent actually. Indent is important in Python. So what you have to do? You have to make the proper indent. So now this is indented. So that this is the class. So we are inside class and then everything is just 4 space away. And then you have definition, and then obviously here is also some issue that you have to give the proper indent. So this also not indented properly. So you have to indent it, and then return is also indented here, and then this function and this look okay now. So now you understand that what was the error, that you have to give the proper indent. So if you are inside class, you have a colon here. So this means the you will start 4 space away, one block. And then you are in definition, so you will start again 4 space away. You can have 4 or multiple of 4 also, it's fine. But yeah, everything should be same. And then you have the return in this function, and then same thing here. So this is done. Now what happens, you can use this class by creating a class instance. So you can use the class by creating a class instance. So you can use the class by creating class instance. So how to do this? So you can say that I have a math function. So I call, let's say, math function short form, and then I call this math func as my, this is my mf is my class instance now. So what we can say that, so mf is the class instance that you have created, or a copy. You can say this is a copy of the class, where class is a more, let's say, broader concept, and you want to do some particular task, so you create a class instance, and that is mf here. Now by using mf, so using the class instance, we can access the functions in the class. So how we access those functions? So let's say mf dot, I call my func1. So dot is very important thing in Python. So we have used module also. Inside module, we have used dot, module 1 dot func1. So there we were calling the module. And then here we are having a class instance, and again we are using mf.func1. So that is the hierarchy that it maintains, that class, you have instance, and inside that you have definitions, functions, and then you call them by using the dot function. And then again, the same thing you can do here, 2, 3, and then you can 1, 2, 3. What is the issue? MF dot. Let me see. Automatically create something. Math func. So definition function 1. Return xy from 2 direction. Positional argument, but 3 were given. Just a second. Okay, map 1, 2, 3. Class instant math fun. There is nothing here, so I'm not sure why this is saying. So you have map.func 1, 2, 3, and you have just a second. What mistake I have made? This is a class with some math function. So you have definition one, then return the value here. Okay. Maybe we have to create, actually, we have to pass here basically self also. Since we have to use this is instance, we are making this as an instance function, so we have to pass the self actually. That should be the case. So for example, since we are making this as a instance basically, essentially this has to become a instance function. Then we have to use the self. Since we are using this for the instance, that's why we have to use the self. So we will explain this. So this is a basically instance method. This is instance method. That's why we have to pass the self. So this is, we can write at the rate instance method, and then we have to pass self as the first argument in the function, in the instance function. So you need not to pass actually self. You can use any other thing. I can pass even, let's say, x, y, g also here. But then you have to use here. You have to use here these things. So it understand self is a very common thing. So that's why we pass the self. But you can use any other thing also. And then it will work like this, and so that's why it is a okay. This. Okay, so in this way, what we have done, we have basically we have to use a self. So self essentially is used for when you create an instance. So let's say if you understand that class is something which is, you can say, more abstract level something. Let's say, for example, you can understand that a student could be a class. So a student, where a student can have their attributes. So a class has its attributes and then methods, or you can say functions, which is a defined term of actually definition as a function. So class has attributes and methods. So for example, what could be the attribute of the student? There could be the attribute could be their institute name, their, let's say, roll number, their hostel name, branch, and everything. These could be the attribute of the students. So we define in a class these things on a abstract level, and then whenever we make an instance of that thing, then we have a particular student. So a student has a name, so that is a abstract level, that everybody has a name. The student has a roll number, a student has hostel, a student has basically branch. But when you talk about an instance, then instance is essentially the detail of a particular student that you create. Maybe student one, which has its name, maybe let's say Arun, its institute, the hostel, and everything. So you have to first thing you have to understand the difference between a class and an instance. So class is something which is, you can say, a broad level properties that you want to define in the class, and then instance are the particular specific or copy of the class where you have specific details. So for example, let's say fruits may be a class, and then mango is just an instance of that particular kind of fruit. It has, let's say, fruit, what the properties are there? Fruit has a color, fruit has a, let's say, taste, and fruit has a shape. All these things are at abstract level. We say that these are the attribute of the, these are a class. But whenever you say mango, then mango has particular thing. It has a color of green and yellow or red, and then mix of all these colors, and then it has a shape, and it has a taste like sweet, all those things. Orange, you have another thing. So these are instance. So that's how we work. So now what we are going to discuss here is that, let's say you want to define a bigger class, and then we will talk about more things. So let's say we have a class, we want to call this student, one class student. And then what we can say that we need not to pass anything here. Then we can say that student has a you can say that they have a institute. So these are institute is basically, there is a institute for all the students, they are enrolled in institute. This we are talking about for a particular institute student. So let's say they are a student of IIT Ropar only. So what is this called? This is called, this particular thing is called class attribute. So institute is a class attribute. So every student has an institute, but this is common for everyone. So this class has a common institute, that is IIT Ropar. Now, generally what happens when you want to create an instance, so you generally use this init function, that is basically when you basically initiate an instance, so you need these things. So you can say that cell and then name of the student, entry number, and then you can have their branch. All these things you basically need whenever you want to create an instance of the class. So when you create an instance of the class, you need to supply all these details. And then you can say that if you want to use this further, self.name is equal to name. So automatically in that particular instance, it will assign the name of that particular instance to be this, whatever name you supply. self dot entry number, it will give you the entry number, and self dot branch will be the branch that ever you are supplying here, this way. So in this way, what we have done, we have basically defined the whatever you need to supply whenever you create an instance of the class, So then what we can define here now, we define basically some functions. So this function dev, and let's say introduction of the student. So this is a, let's say this is a function we want to define, and so we want to use this as a instance method. Since if we pass self here, so this self and this self match. So this self, when you create instance, this automatically initiate the detail. You need the following detail, and then you can say that this go to the instance. These details connect to the instance. And then this method also, we want to make it an instance method. And then what it does, this is the introduction of the student. So we can simply just print something that, or whatever you other thing you want to do. And you say that my name is, and then you can say that self name. Since self dot name is available now with the instance, self dot name is available with the instance. This one plus, you can say that, and my branch is, whatever you say, self dot branch. So in this way, what we are doing, so you are, whenever you create instance, if you call this method, it automatically will give the name. So you have to understand the self. So self is basically associated with the instance. That if you supply a detail of a student like name, entry number, and branch, then if you call this instance method, so you can get the detail of the student in this. So this is the instance method. We want to define a class method. So you can call this definition, and then you can say that, okay, change something, we can call this change branch, or actually change, not branch, we can call institute. And then this is a class method. So we have, for class method, for instance method, you pass self, and then for class method, you have to pass CLS and new institute, whatever you want to change. So essentially, this is a class method. And let's say you have to pass here CLS and new institute. And then you can say that so let's say we want to do something that, okay, the old institute name is, and then you say that. So note that this institute is a class attribute. So you can access it by using the CLS. You can access it by using a CLS function, CLS.institute. Since that is a class attribute, so class attribute can be accessed by the CLS. So cls.institute will give the old institute name, and then what we want to do, we want to change it, right? So what we want to do, we want to change it. So you say that, okay, now cls.institute, that new institute become the whatever you pass the new institute here, this one. And then you can say that print again the institute is changed to whatever you write, the new one. Remember that in this case we have changed it. Now the class institute has become the new institute. So in this way, you can change this institute by using this method. And so this method do something. So now what we have done. So in this case, we have a class attribute, right? Class attribute. And then we have this init function which instantiate the instance, right? And then you have this is the, you can say, instance method. And then you have a class method. Class method basically, you have this method, class method, right? Okay. Then there are other kind of method which are generally neither associated with, you can say that this is called static method. Static method, where basically you can say class method are connected to class generally. The static method are basically, so you can have a static method where you can, so generally let's say the instance method is connected to instance, where you, this is related to instance related work. So generally in static method, you can put general thing. For example, let's say I put definition something, motto of the institute. So which can, you can say that this is static method, and then you can, uh, you don't want to, let's say, change it, or you don't, let's say in class attribute you can change by using this change institute command. And here this method essentially you have just fixed thing, so you can put here, uh, let's say this is the motto guide or the right path, some motto of the institute, you can put here something. So motto, sorry, so this is not the motto, we can write it this way. So print, and then inside this we have this. So now we have defined some functions where we have include a class. So class essentially means, as we discussed, that this is the blueprint or theoretical concept where you want to have certain attributes, certain methods, and everything that comes under class. When you call an instance, when you make instance of the class, then you have a specific student in mind, which has its own name, entry number, and branch. And then you can have basically class method and static method, and then we can basically use them. So the first thing that you can create a student, let's say student st1. So you can create this student. Okay, we have to run it first. So it's saying that intent is not matching before. So this one is not matching, I think. This is fine now. So there is indent issue. Indent is very important in Python. So you have a student, but remember that when you are creating an instance, so you have to pass all these values. Otherwise, it will give an error. Since when you are creating instance, it automatically run this command. This command. When you create instance, it automatically run this command. This is the first thing that it does. And then if I pass it without any value, it will give me an error. It is saying that you have to pass all these things. You need missing 3 required positional arguments: name, entry number, and branch. So I have to pass all these things to create the instance. So name, I can give something, and then I have to give the entry number. So let's say 2022 CS1. This is the entry number, and then you have to give the branch. So branch, essentially you can give, let's say CSC, this branch. And now this is created. ST1 is created. Now by using this instance, you can access the attributes. So these are the called the instance attribute. Instance attributes. So instance attributes you can access, right? So instance attributes are like name, entry number, and branch. So you can access the name here. For example, you can access the instance attribute like name. What is the name? So name is Arun, st1 dot. You can access the entry number, st1 dot. So this is a particular student that we are talking about. So you can access all these details. Further, you can access, these are the attributes of that particular student. Now you can also access the institute. You can access the institute. So that is a class attribute, but you can access it for every instance. So let's say this is the class attribute is used for every instance, right? So similarly, I have access these functions. So similarly, I can create another instance, st2 control v. So you have, let's say, another student, and then its branch may be different. So this student, oh sorry, we can, I made a mistake. So this is called st2, and then st2 also have the same institute. Since this is a class, it can access the class attribute. Every instance can access the class attribute. So st2 dot institute. You can have, again, just I'm repeating the name. You can have this its name and all those things. You can also access the, so you can access the by student dot institute in this way also. So this is not by using the instance, you are using it by using the class itself. So you can access the class attributes using class or using instances, whatever instances you have created. So we can have another attribute here, address is equal to Ropar, Nagar, Punjab. So this way you can have another class attribute, and then this is also common for every student. student dot address. So this is the address, and then this also can be accessed by st2 dot address. So this is the address of the, you can access it by class name, or you can access it by using the instance. But if you put student dot name, so it is showing an error, since so student doesn't have a attribute name. Only instance has a attribute name, but a student doesn't have a attribute name. So a student as a class, it doesn't have a name, but so that's why you cannot access this thing by using the class name student, but you can access the class attributes either by using the class name or by using the instance name. So this thing can be accessed only by using the instance. Since these are the, as we discussed, these are the class instances attribute. So we have written here that these are the instance attributes. So these can be accessed only by use, due to this self function. This can be accessed by the, by basically the instances. And now, so this is also a instance function, instance method. So what we can write, then you can write st2 dot intro of the student, and then you need not to pass anything, then you can enter. It's saying that my name is Arjun and my branch is ME. So in this way you are able to access. So this is called accessing the, actually you have to write it. So this is the accessing the instance method. So you have to have the instance and then you have the method name. So let's see what happens if you try to access it by using the class name, student dot intro of student. So again, it is saying that there is an error. Since this method you cannot access by using the class name. If you, let's say, pass itself here, it's saying, but it will give again an error since it doesn't understand this thing. So this self is not defined. That's why you cannot access it. So what we are doing, trying to access. So we're trying to access the instance method using class name. Class name. Okay. So far so good. So now let us come to using this static method, whether we can access the static method. So let's say you can st2 dot the motto, that is a static method. So you can see that you can access the static method using class instance. We have accessed it, right? You can get the result. And if you want to access it by using the class name, auto, you can access it. So you can access the, so you can see that whenever there was a method that is intro student, that was a instance method essentially, since self was passed inside that, so that was an instance method. So it was only accessible through the instance, but not by the class name. But here this static method is accessible by using both. So is accessible using class itself, class as well as instance. Okay. Now we want to see this one, this class method. So class method basically you can access by using the basically class only. And then, so let's say what you want to do. So you want to change. So let's say a student dot change institute name, and let's say institute name become IIT Bombay, IIT B. So what is saying that the old institute name is IIT Ropar, the institute is changed to IIT Bombay. So this class attribute has changed now. The class attribute has changed now. So if we see st2 dot institute, so now it has become IIT Bombay. So basically you have changed the attribute. So and that is changed for basically all the instance. Whatever instance you create now, let's you create a new instance st3 that is something student let's say Ram, let's say roll number, some roll number CS2345, and then branch some EE, and st3 dot institute. So it has changed now. So if you see that you have basically whatever the class attribute was there, you have changed it. So it is changed. This change is applicable now. That institute has changed now. The IIT Ropar that has changed to IIT B, and then this is applicable for all the whatever math you have instance, or whether you have all the classes. So you can say that student dot now institute is changed now. Whether you access it through the instance or whether you access it through the class itself. So it has changed now. Now, what is the takeaway from this? The takeaway from this, that if you see that every class has basically class attributes and it has basically some functions. So this is this is also one particular function that initiate instantiate the instance. And if you have the this is underscore double underscore init function, so you have to pass all the arguments to create the instance of that class. Okay, and then you can have class methods and you can have also the instance methods. So at class method, generally we write this one, class method, and then the class method is accessible by using the class name. Instance methods are accessible by using the instance that you created. And then the static method can be accessed by using either the class name or by using the instance name. You can access the static method by using any other thing, either instance or by the class name. Both things you can use here. So, right. If you want to access the class attributes, that class attribute can be accessed by using this one, either by using the instance or can be accessed by using the class itself or instance. It can be accessed by this. So this way you can define a class. Okay. So in class, generally what happens that you also have, you can also define subclasses. Subclasses. So how do you define subclasses? So in subclass, essentially what you do, so in subclass, what you do, you can define, let's say, I want to define a particular kind of student. So we can again define class, and then you want to define, let's say, undergrad, and then these are basically a subclass of the, so you have to pass that class name, student. So we have already a bigger class student, but we have essentially subclass. Okay. Subclass, and that is derived, this is subclass of the student. Now also you can, what you can do, you can instantiate it again by using the same thing, that you can say that uh, you can have there may be some attribute here. So let's say you can have institute, that is here IIT, let's say Ropar. They can have another, this one, and then there could be again definition underscore in it underscore, we can have something like cell, and then let's say hostel, something would be there, and then cell dot hostel, cell dot hostel is equal to hostel. So this is one function that we have defined, and then you have definition. You can have like something here, like you can have intro, we can have the same function here, we can have, let's say, the same function that we have defined above, this one. So definition, this one, so, and then obviously we have to pass here name and branch, name and branch, and hostel may, it may have some other thing also. Self dot name is equal to name, self dot hostel is equal to hostel, and then it has a introduction here, and then you can see that you can have another function definition intro, let's say 2, which is cell, and then you can say that another introduction we can write. Just we want to create, we want to see that uh, if we call this same function, so, and my let's say node branch, so that we call this my hostel is self.hostel. You want to differ it from the earlier one little bit in the printing, and you have so anyway, this may not be even required. So this way we have a subclass. Let's say this is enough, I think. So we have a subclass that is basically derived from the student, right? Now what you can do, you can again create instance here. So let's say UG1 undergrad student 1. So that is undergrad. You have to pass name Rohan, you have to pass branch, let's say CSC, and you have to pass hostel, let's say some BIAS hostel. So in this way we have created an instance of the this subclass. Then UG1. Now what you can do, if you search the institute, so institute is defined here, so automatically it takes the institute, and then you can see that the institute is IIT Ropar. It take from here, whatever is defined here. So remember that in above, in the, let's say, student class, if you see ST1, that is instance of the student, bigger one. So where we pass the name is again ABC. You pass the roll number CSB 111, and you pass the branch. So that is metallurgy. So if you see here ST1 dot institute, so that institute is IIT Bombay, IIT B. So you see that what it look the local one, local variable available. You can say whatever available here. So it doesn't look the parent one, it look the local one. The parent has institute, they're written globally as the IIT Bombay, that we have changed. And then here basically the subclass has IIT Ropar. So this will take the IIT Ropar, and then the bigger one ST1 will take the IIT Bombay. Now we can see that, let's say UG1 dot address. So it is taking the same address, the parent one. Since address is not defined here, so we have not defined the address. So you can see that if you see, so what it does, so address is not given for the subclass, and hence it will look in the parent class for the address. So address is not given for the subclass, and hence it will look in the parent class for the address. And if it is there, it will print that. So, but if you say that UG1 dot, let's say city. So city is not defined there. Neither city is defined in the subclass, neither city is defined in the parent class. So that's why what it will do, it will give an error. It will say that city is not defined. You have not defined the city. So it doesn't have a attribute city. So it cannot look for it. So that's why it is giving an error. Now, next thing is that, let's say we say that UG1 dot intro of the student. So this is a function, that's why I have to pass this. So it will take the local one, whatever name is here, this one, and it will say this address. My name is this, and my hostel is the hostel that is given here. So if you see if let us change this address to intro student 2. Okay, so in this way, so we have to see branch. So it is saying actually undergrad student, we have pass Rohan CSC branch name. Okay, we have to actually change this. I have not passed this. So self name, self dot hostel, self dot name, self dot. Okay, we have to pass branch actually branch. This thing actually we missed. That is used actually here. We have to pass this. We have written this thing. So self dot name, self dot hostel. So now it should work fine. Okay. So then what it is doing? So when you calling UG dot introduction student, so this function is not available. So intro underscore student function is not available with the subclass undergrad and hence it will use the parent function, right? That is there. So that's why this is. But since we have changed the name here, we are using, there is no function intro student there, but there is a function intro student 2. So if you want to use that function, so it will use the its local function ug1 dot intro student, and then let's say you say intro student 2, intro student 2. So then it will be using the function that my name is Rohan and my hostel is Bias. So one function is available locally, that is intro student 2, which it will take from there. And if it will use the parent function. So there is a hierarchy. So it look one level up and then keep going. If there is a, you can have a subclass of the subclass also and so on. So you can have several hierarchy. So what it does, it look first locally, and then if it is not available, it look in the parent attribute. And if parent attribute is not there, it look in the grandparents attribute and so on. So that's how you can create. This is called hierarchy in the classes. And now similarly, this can call also the motto. It can call motto also. So motto is not available here. So motto is only available in the basically parents, not here. So motto can be called by st1.motto. So you can see that motto can be called by, since there is a parent function, so you the subclass also can call it, the instance of that class, parent class can also call it, and even the name of parent class also can call it, like a student, as we discussed. This can be called by everybody. So this function can be called. So generally what happens in hierarchy, so it look with the local attribute or local function, and if it is not available, it go one level up and then it basically check there. Okay. So that is there. Okay, so there is what you say. There is please recall to the end of the section. clearly. Some students are writing some message, problem in object. Okay. Okay, so now I hope that it clears you the, let's say, concept of a uh, class, concept of the instance. So object, if, so there people use class, object, instance. So instance and object are almost same thing. So they are just used interchangeably. Object, and you can say that object, object is a particular thing which has certain characteristic, and object and instance are used interchangeably. Class is, you can say, blueprint, and object and instance are the particular, uh, you can say, or specific, uh, you can say, copy of the class. So that are your object. So however, some people may have a philosophical difference, that they can say that object refers to some memory location or where it is created and all those things. But yeah, object and instance are used basically uh, interchangeably. So then you can also, so you can see that st1 row. So you have here these things. So essentially these things are available for the st1 branch, entry number, institute, motto, name. These things are available for the, it automatically identify these things. These things are available for the instance st1. Then similarly, if you see that ug1, so these functions are available. You can have address, branch, change institute, and all those things. So it has taken function from its own functions, and it has taken functions from the parents also, and so on. Okay, so I think that I hope it clears your, let's say, uh, this part, class and instance. So today what we have discussed so far, we have discussed like the, let's say, how you create your own module, and then we have discussed about what is the class, and what are the class attributes, what are the instance attributes, what are the class functions, and what are the instance functions, and what are the static class methods, instance methods, and static methods. And then how to create a subclass out of the class, which can basically access the attributes and functions of its own. And if they are not available, it can access the attributes and functions of the parent class. So that is one thing. So next thing that basically you can look for. So once you have actually access to, let's say, once you understand in Python the variables that we have discussed here in the beginning, once you understand how to import different kind of library, once you understand the looping, for loop, while loop, if else condition, and once you have, you can create your own functions by using the definition command, which we have discussed. You can create your own functions, and then if you also know the objects. So this is actually good enough to basically start. So this is good enough, and then more you learn basically by using the things. Since when you keep using the things, you remember those things. So ultimately it depends on one particular domain that where you are working. So for example, if you are, let's say, working on your project, math project, then you may use basically numpy and scipy. Scipy also you can use very often. Scipy, that is also very like important library. So just you can call scipy by this command, and then you can also see the help file of SciPy this way. So it has actually, this is a called a scientific computing package for Python. If you see here the name, and then it has very good like functionality. So you can see that, okay, you can have here clustering, you can have fast Fourier transform, you can integrate, you can interpolate, and so on. You can have linear algebra function and all those things. You have optimizers, different optimizers, and all those things. So it depends actually what application you want to use. So SciPy is, let's say, very important library. Right. So for example, if you want to see the help of SciPy dot integrate, so we can say what is the function integrate, integrate. So SciPy can say SciPy import. I'm not sure where it is there. Integrate is there, this function. So essentially you have to when you, the idea is that when you basically work with different, since there are so many things actually, so one cannot be master of everything actually whatever available in Python, since these things are based on subject knowledge also. These are not something that are based on just you know the coding. So you should have the good knowledge of subject also. That's why one person cannot do everything. So whatever is good, whatever you are using, that you only know those things, right? So that's why this is important, that whatever you use. So just you can see that how you have different actually functions here. This one, just I want to particularly want to use some function, let's say regression. Actually I want to use import, just I want to use regression. Actually I need to see how, actually regression is very important concept when you move to data science. So that's why we can just try. So we can just try linear regression. That's why I'm thinking that whether we can basically see the regression part from here. So generally how we use it, so just I'm doing that. So what you have to do, so we have to use import numpy as np also. So basically what we are doing, we want to just see whether you can use the regression also. So I'm just exploring one more library which is very useful, that whenever you work with, let's say if you are a student of engineering, but if you are working with some data, so regression is a very common tool that you have to use. So SciPy has very good like stat library, that's why we are calling this from SciPy import stats. Okay. And then what you have to do is you have to essentially create the data. So how you do the regression essentially, let's say I have a variable x that is just I can pass a list, or I can make this in array, np dot array, and then I have, let's say, some number, Just this is again a hypothetical data 9 and let's say 10. So we have 10 points, and then we have our y is equal to 2 2 into x plus 3. So we have created the data by using this one. It's a hypothetical data. So generally what happens that whenever you work with the data, that data is stored in your computer, so you can read it. But just to do it, I am just creating a hypothetical data, and plus I hope it will work. Red, and then 0 1 size 10. I'm not sure whether it will work. And is NP. Okay, okay, I have to add actually some random error to this. So this is my x, this data we want to use, and this is our y, and we want to see whether there is a regression. We want to regress them one on another. But before that, we want to add random error to this. So let's generate error. Error basically you can generate by, as we covered this part, random dot normal, we covered this part already. So that's why 0 1 and then 10. So y is equal to, we are generating just hypothetical data to work on, and then this is my y. And then so we have generated random error to these values. So then you can see plt dot scatter. You can see that you can plot x and y. So you can see these scatter plots. So you can see this data. Just we have generated a hypothetical data to work on it. So you can see that you can fit a linear line between them. So regression basically means if one variable to given to you, and then you can get the value of another variable. So regression is used essentially in many applications. Okay. So you can have regression you can use in many applications where you have basically, this is called simple linear regression, and you want to predict the value of another variable. This is called dependent variable based on the independent variables. So that's why you want to do it. And then essentially this means you want to fit a best fitting line between these data points. That is the purpose. So best fitting line essentially is that line which is basically close to all the point, but this is a straight line. This is not exactly passing through all the point. So, but close to all the points. So this kind of problem occur very often in whenever you have in many situations actually. So for example, you want to, there's an economic theory that says that expenditure depends on the income. So if people income increases, expenditure increases. So what happens? This is economic theory, comes in economics. Now, how you verify it? So what generally people do to verify economic theory or to draw conclusion, what they do, they collect the data. So they ask, let's say 100 of people, their expenditure and their income. And then if they plot them on x-axis and y-axis, make the scatter plot, then they will see that, okay, there is a trend. Like if person income increases, their expenditure also increases. But that is not a perfect relationship. Like you cannot perfectly tell that, okay, if you give the income, what will be the person expenditure? Since a person with income 1 lakh per month may have an expenditure of 20,000. Another person with income 1 lakh may have an expenditure of 30,000. One person with income, another person with income 1 lakh may have expenditure of 40,000. So your aim is not to precisely predict the things, but to fit a best fitting line so that you can tell on average rather than telling the exact value. So that is the purpose here. So what you do in regression, essentially, once you have your data, so you want to fit the regression line between them, right? So what you do, so sorry, so what we do here, so we say that regression is equal to stats dot linear regression, and then you have to pass your x and y. So this is the regression dot coefficient regression. So you have your linear regression result. So generally the result look like, you can see here that the slope is 1.89, this one, and intercept is this one, and then this is the R value. Maybe those who have not may not be familiar with the basically concept like regression, so they may not they may have some issue in understanding, but you can see that it has given a regression line like this. Y is equal to, if you have to write it, 1.89 plus 3.43 into x. So this regression line, it has given that if you fit this line, so it will be the best fitting line between these data points. And then if you have this line, you can predict the value of y if x is given. So for example, so if you go in the machine learning context, so in machine learning context, we say that first you train your model on the data. So this way, we are training our model where we have x and y, and we are building a model which is y is equal to, this is a very simple model, but this is the first step of, you can say, building machine learning model, that you have y is equal to 1.89 plus 3.43x. So this is a trained model. This also can be called as a trained model. So this can be called as trained model on given x and y. So generally this is called, this kind of problem is called supervised learning. So this is supervised learning thing, where you have train your model based on the data. Now what you have to do, the further you predict the value of y given some value of x. So this way you are using your model to predict your y by using x. So for example, let's say we have 100 of household data of income and expenditure. We build a model, and then once you have a new house, new person with the income available to you, then by using your model, you can tell the what is the average expenditure of the person, how much he can spend. And similarly, whenever all these business company they look, so they see that okay, they already understand that okay, person with good income will have good expenditure, so they keep contacting them for credit card, cars, and other things. That okay, he has money, so he's going to spend. That is the economic theory. So they keep contacting those person. So that is the thing. Similarly, there could be example. Let's say father height and the children height. So you know that children height depend on the parent height. So the problem could be whether first you have heights of parents and their children's, and then once you build a model based on that, then the problem will be that okay, this is the father height, let's say 6 feet, and then what will be the average height of the children. So you cannot tell exactly, but you can tell the range that okay, in this range this should be the height. So this way this regression framework works. So another very important library that we have not discussed, that is called sklearn. sklearn, this library. So sklearn is very, let's say, this is the machine learning library that we have not covered, but since it needs a lot of time, this is the main machine learning library with loads of functionality. With lots of functionality. So even if you see it has all the model. If you basically want to work in this area, then it has all the models available, inbuilt models. Sklearn. Sklearn. Okay. So basically I have to, so just so this is I have to basically, this is giving error. So I have to import it first. So import, since it is not understanding this SQL, you can see that this library which has, this is a machine learning module for Python. So whatever the machine learning modules are available, that are available in this library, sklearn is a Python module integrating classical machine learning algorithms in the tightly knit world of scientific Python. And then it also use basically NumPy, SciPy, Matplotlib in the background. So obviously these modules are available. It use all this, and this is the website. So obviously you can visit this website to get the idea. And then if you see here, if you go a little bit down, you can see that it has a very rich library. Let's say clustering, covariance, and decomposition. Decomposition basically are used for dimension, matrix decomposition. Matrix decomposition. So it has, you can see that there are so many packages here in this way. And then you can see main thing that, okay, you have to, it has given some help also so that you can work with this library efficiently. So this is the main Python library here, sklearn. So I think we have covered the important libraries little bit, may not be all the aspects. So if just I recall again once more to you. So essentially, you can see that NumPy is very important library where you can basically do all the work related to linear algebra, matrix operations, arrays, and even let's say you have a scalar, then you have arrays, then you have matrix, and then you have tensors. So tensors are, you can say, collections of matrices. So array is a collection of scalars, and the matrix is a collection of vectors or arrays, and then tensors is a collection of matrices. So tensors are very useful when you have this audio or video kind of data, where this with time actually you have different matrices actually, different matrices. So that's why tensors are important there. When you keep collecting your audio video data over time, so that becomes, you can say, this is a collection of information over time. And then there is a module that is called TensorFlow. TensorFlow is also a module in Python. So I'm not sure whether this is installed here. So TensorFlow is another module where you can, there are image processing modules where if you want to work with the images, you want to, let's say, compress the image, you want to extract different features from the image. All those things are available in image processing module. So we have discussed NumPy little bit, that how to use some functionality of the NumPy. Matplotlib, which is a very, let's say, rich library, Matplotlib. So we have just plotted some basic functions, but obviously there is a lot of things available here. Then there is also library that is called, it also a very good plotting tool that is called Seaborn. This library, Seaborn. We have not discussed it, but you can explore Seaborn also. So you can see that this is a very rich library in terms of, again, floating and other thing. So this also complement the matplotlib library. So this library, again, you can see this also, Seaborn. It helps also in floating. Then we have pandas. Pandas essentially is nothing but you can basically explore time series, and you can explore basically data frames, where data frames are nothing but a collections of rows and columns, and then you have to exploit them. You have to drop, you have to add something, you have to do some operations along the x-axis, along the y-axis, and something. So this pandas is very rich library in that context. If you go with the scipy, so scipy we have not discussed. So scipy you can do basically all the, let's say, scientific operations, fast Fourier transform, signal processing, optimization, regression, and then many other things are available in the scipy library. And there is a library that is called SymPy. So SymPy basically used for scientific computation. So scientific computation. So this library basically use the symbolic computation. Sorry. So this library is used for symbolic computation. So symbolic computation basically means, for example, if you want to, let's say, differentiate sin x. So in that case, symbolically it will give the result, let's say, cos x, and then you want to integrate something, it will give the symbolic results. So that is this is called symbolic computation. So for example, you want to calculate the Fourier transform of something, you want to integrate, you want to differentiate, all these things can be done in SymPy. Then matplotlib we have covered. Then there is 3D plotting. So you can do in Python 3D plotting. 3D plotting library are there. Plotting libraries are there. Libraries are there. So you can use these libraries for 3D plotting. That is, I think, matplotlib 3D itself. So you can use that. And obviously we have talked about let's say sklearn, that is machine learning mainly. TensorFlow you can use. You have image processing tools. You can use all these things. So that's why nowadays many people basically use time basically Python, since there are loads of functionality available, and you need not to write all the codes yourself. You need to have obviously the good subject knowledge. So whatever subject you are want to use it, and you can see that okay, there are so many functions available that you can do many things without writing very lengthy codes. So that is the very good part of Python. Further, for example, let's say in your institute, wherever you work, let's say you are working on something. So if you want to use MATLAB, so MATLAB is a very costly, it has a costly license. So Python is free. So that's why you can save money for your institute, and even you can install it on your home computer, desktop, whatever laptop. So you need not to spend money to take the license of Python, sorry, MATLAB. So that is also another good thing. Further, people used to use R software, that is a statistical software. So however, I still feel that whenever I use R, there are many functions which are related to statistics and time series analysis and others, which are available in R, but are not available in Python. But Python is actually developing very fast. So I feel that after some time, whatever available in R language will be available in Python in a short time. So I can say that uh, R is still a very rich library. In terms of statistical functions. but Python is catching it. So I think that's all from my side. I should stop here and we